So we're going to start apportionment today. And basically, apportionment is the idea that you want to give things out. Now, when we give things out, typically we think of these things as like representatives. So we're going to deal out representatives in an attempt to do this in a logical way. And it doesn't necessarily have to be representatives, but probably the best example is representatives. For instance, in the United States House of Representatives, you have to deal out a certain number of representatives to each state. We're going to start dealing out a certain number of representatives to different, in this class, districts. Now, let's take the following example. Let's pretend we have 100 representatives to deal out. And we have 5 districts, A, B, C, D, and E. Now, each of the districts has a different population, but the total amount is 100,000. So if you think about this, we have 100 representatives, and we have 100,000 people. Now, since we have 100,000 people, and we have 100 representatives, it's logical to say, well, let's take that population, 100,000, divide it by the number of representatives, and that gives us a standard divisor. And if you think about that, that would mean roughly, in this case, 1,000 people, in fact, exactly, 1,000 people would be one representative. And the idea of the standard divisor is essentially that, is to get a number of people per representative. So in this example, our standard divisor was 1,000. And what we're going to do is we're going to make each district, we're going to give a quota. Now a quota is simply the actual population divided by the standard divisor. That's going to give us a quota. So for instance, if the population of District A is 38,343, we divide that by the standard divisor, which in this case was 1,000, and we're going to get a quota of 38.343. So in a perfect world, District A would have gotten 38.343 representatives, because out of 100 it has that percentage. In fact, has 38.343 percentage of the population in this example as well. Since each of these populations was divided by the standard divider, if you actually add up all of the quotas, you're going to get the total amount of representatives we want. So that's a very nice property to have. Now the problem with the quotas is that this fractional part throws us off. Remember, we wanted to allocate 100 representatives, and 38.343 is a fine enough number, but it doesn't work when you're trying to give out a whole representative. Nobody can have 0.343 of a person. And so what we need to do is we need to establish kind of some rules of how to deal with these fractional parts. Because again, we can't assign a fraction of a representative to some population. And it's not quite as easy as it may seem. You may think, let's just round everything down. Now, if you take your quota and you round everything down, or in other words, you go to the next lowest integer. So for instance, if we have 0.343, we round it down, or we take it to the next lowest integer, 38. Even if we have 0.899, we take it down to the next lowest integer, which in that case for district C is 4. So if we take everything to the next lowest integer, mathematically, by the way, this is called a floor function, then you see that our total is only going to add up to 98 representatives. Now, if we go up with everything, so we take what's called mathematically as the ceiling, we go 38, has a little fractional part, so we add that, make it 39. 4.899 is district C, move it up to 5. If we move everything up, then in the total we get too many. And even if we do standard rounding doesn't necessarily get us to the right amount either. In fact, you see in this case, we've only done 5 districts, and with the way they're allocated, doing standard rounding with each one, standard rounding by the way, obviously, if its decimal point is 0.5 or greater, you round it up. If it's less than 0.5, you round it down. So if we do standard rounding, we don't come up with the right total either. And this is an issue because now we have 99 representatives. We want to fairly allocate 100 representatives. And these three just standard mathematical procedures of using a lower quota, that'd be the floor, the upper quota, that's the ceiling, or standard rounding, don't give you the right number of representatives. So we are going to look at 4 different methods of how to deal with this fractional problem and how to get rid of it. And these methods are the Hamilton method, the Jefferson method, the Adams method, and the Webster method. Now, if you notice, these are all names of, basically well-known figures in American history. All right? And each of these has a different method. Each of these has particular disadvantages and advantages. And we're going to look at all of those kinds of things together in the next few sections.